Evening, y'all. This is our exam one. So question one, we have vector u, vector v. Here, let's do this. Vector u, vector v, and vector w. Okay, so 2u will be 2, -2, -4, plus negative vector v, that'll be -3, 1, 0. And then w is 6w, so 12 minus 6 and 6. And then if we add these up, so 2 and -3 and 12 should be 11, and it is. And then -2 and 1 is -1, and -6 is -7. And then our last one, -4, 0, -4, and then 6 is 2. All right, parallel vector, length 4 in the direction of u. It'll be 4 times vector u. U was 1, -1, 2. Divided by the unit vector, or the length rather, of vector u. Length of u is 1 plus 1 plus 4. And this is 4 over root 6, 1, -1, 2. That works, or you can multiply the scalar in, make it 4 over root 6, -4 over root 6, and 8 over root 6. But again, either of these, this one or this one, should work. Then u dot v, we take u, which is 1, -1, -2, and multiply it times vector v. V was 3, -1, 0. And then you are going to get a scalar, and you multiply component-wise and then add those up. So 1 times 3, -1 times -1, 0 times 2. So 3 times 1 is 3. -1 and -1 is 1. 0, -2 is 0, and we're going to get 4. Projection of u onto v is the shadow of u onto v. It's a scalar multiple of v, and it's u dot v over v dot v, and then times vector v. U dot v, we calculated a moment ago, u dot v was 4. V dot v is v dotted with itself. V dot v, v was 3, -1, 0. So v dot v, 3, -1, 0, dot with itself is going to be 9 plus 1, and that's 10. And then times vector v, 3, -1, 0. So you should at least reduce the 4/10 into 2/5, and it's fine to leave the scalar multiple on the outside. That's a 3. U cross V, it's a I, J, K, a 3 by 3 determinant. U comes first in the cross, so vector U, 1, -1, -2 is in the second row. Third row is vector V, since it comes last, and that's 3, -1, 0. So we end up with a vector. The middle component is always negative to begin with, and then we calculate. All right, so the I component, first component, is going to be the sub 2 by 2 determinant. When you knock out the I column and I row, it leaves you with this 2 by 2 determinant. Determinant would be 0 minus a positive 2. So 2. Oh, sorry, -2. -2. Here, let's write that out. 0 minus 2. The middle j term. Knock out j column, j row, sub 2 by 2 is 0, minus -6. And then u cross v third component, k column, k row, leaves you with -1 minus -3. And that is -2, -6, 2. All right, moving on, convert r equals 3 sine theta from polar to rectangular. If you multiply both sides by sine, then you get r sine theta is 3. And r sine theta was y, and that's 3. In a picture, here's some point and some angle theta and some distance r, and the y value. This is some point x, y, and its equivalent. X is r cosine theta, and y was r sine theta. This is why we're saying r sine theta is equal to y, and in this case, it's 3. So y equals 3. Then line segment from point to point, T0. Okay, so we need, okay, here's point P, we'll say. Here's point Q. We have a vector from, so it's from P to Q. So here's our direction vector for our line, and we need a point and a direction vector. So P to Q, that's going to be vector PQ, and that's the Q pieces minus the P pieces. Okay, so 7 minus -2, that's 7 is going to be +2. 1 minus 6, 4 minus 3, we get 9, and -5, and 1. That's our direction vector. So then our line segment, let's see, r of t is going to take the initial point as a position vector, -2, 6, 3, plus time, a scalar multiple of 9, -5, and 1. That should work. Time being from 0, I think, to 1. Let's check. If you plug in a 1 for t, then that'll be this vector plus this vector. That'll be 9, and -2 is 7. 7. And -5 and 6 is 1, and 1 and 3 is 4. It gives you point Q at time 1. So start time is 0. That puts you at point P. End time is 1. That puts you at point Q. All right, and then the parametric pieces x, y, t are when you combine these things. Let's see. So if you can combine the vectors here with the scalar multiple t, it would be -2 and 9t, 6 and -5t, and 3 and 1t. So if we write that out, it would be -2 plus 9t, 6 minus 5t, 3 plus t. Segment of the circle, that's a circle, center 0, 0 with radius 4. Okay, so center 0, 0, radius 4 for cosine theta, for sine theta, and let's see, from point 40 to point 04. So 40 is here, 04 up there. So we're just doing the quarters worth of circle. There we go. And it goes counterclockwise, which is the default direction. So r of t would be the x piece, which is for cosine theta, y piece for sine theta. T interval goes from time 0 to pi halves. This is theta being, or time being 0. No, I need to correct that to theta. Theta is 0, theta is pi halves. The x piece is for cosine theta, y piece for sine theta. I think that's right. I'm going to check real quick. Let's see. Yeah, that works. Equation of a plane through some points. Right plane is standard form. Okay, so here is point P. Here's Q. Here's R. Together they determine a plane. Maybe it helps, maybe more to draw a plane. Here's P, Q, R. Doesn't matter. Here, let's put P there, Q there, R there. In the end, those 3 points lie in the plane. To determine the plane, you need a point in the plane. You need a normal vector. To get a normal vector, a vector like this, we'll say, you need to take 2 of the vectors that are lying in the plane or parallel to the plane and cross them. So let's say we build vector, let's use bright green, QR. That's QR. And then we cross it with vector PQ. That would give us vector n, the normal vector going down through the page with the right hand rule. You point your fingers in the direction of the green vector, which means you have to turn your hand upside down, curl to the pink, and your thumb will point down through the page. Okay, so QP, QP. So QR is R stuff minus Q stuff. So 0, so Q, R minus Q. So -2, 3 minus 0, 0 minus 0. QP I'm watching the As game. I think they, oh wow, it's 3-2 now. Okay. Q to P. Q to P. No, I gotta focus. Okay, so P minus Q. -2, 0 minus 2. 0 and 0, and then 1 minus 0, so 1. And then we're going to do QR cross QP. We could do QP cross QR. It doesn't matter which order, but this is just the order I wrote it. And then let's just use some ad hoc notation here to make this work for us. All right, so that's going to be, let's see, that and that. That's going to give us 1 minus 0, and that's, or 3 minus 0, that's going to give us 3. Then J column, J row, that's going to give us -2 and a 0 there. So -2, and then it's already negative, so +2. Here, let's do -2. And then the last K column, K row, that's 0 minus -6. All right, so that's our normal vector. And any scalar multiple of that normal vector would do. So 3, 2, 6. So then how do we do this? Normal vector. Okay, so then your equation will be 3x plus 2y plus 6z. And then the right side is the dot product between that normal and any point from the plane. So if we take the dot product with the normal and any point from the plane, I'm going to use 0, 0, 1 because that'll be quick to deal with. That's going to be 0 plus 0 plus 6. 6. Now I'm going to go back. I'm going to erase some equal signs because I don't know. Like the notation I used here is not the best, but I'm not graded on notation here. Graded on simplifying, coming up with the equation of the plane. Then let's see. Oh, determine if they're parallel, intersecting, or skew. So first decide if they're parallel and pull out the normal vectors. So normal vector for r of t, or sorry, the direction vector are the coefficients of t. So for line r, we have 2 and 4 and -1. And then line big R, our parallel direction vector is 2 and 1 and 2. 2 and 1 and 2. And no, they're not scalar multiples. Line R is not parallel to line big R. Do they intersect? Let's see. Let's pick. Okay, so let's switch colors. Okay, so let's pick. How about the X pieces and the Z pieces? The idea is to take two sets of components, the X components, the Z components. That's two systems of equations, solve for T or S, and then find your T and S that make those true, and then plug those back into the missing component, say the Y component. So for the X's, we have 3 plus, Dallas just scored, 3 plus 2T equals 3 plus 2S. And for the Z component, let's switch colors. Let's go gray. For the Z component, 2 minus T would be -2 plus 2S. And the idea, we got two equations, two unknowns. We can solve for T, we can solve for S. And this will find us a time T and a time S that makes the two lines begin to match, begin to meet in the same X and Z coordinate, but potentially not in the Y. So let's see. I think let's over here on the Z side, I want to solve for T. So let's see, 2 plus 2 minus 2S is going to be T. That's 4 minus 2S is T. And then take that, plug it into the X piece. So 3 plus 2 times T, 4 minus 2S. So 3 plus 8 minus 4S, 3 plus 2S. And so that's a 6S on the right. The 3's cancel, I get 8. S is 8/6. That's going to be 4/3. Then, and I'm going to check. S 4/3. Do I get 4/3? Oh, you know what? I should know better. S has to be a 1 for that to be true. How could, let me look back here. So 3 plus 2T equals 3 plus 2S. For these to be true, S and T have to be the same. And is that right? Yeah. Then, okay, let's see over here. 2 minus T, -2 plus 2S. So if I move the T over here, I get a T. Dallas just scored again. Unbelievable. Now it's 5-2. And then move the -2 and the 2S over here. So that's 4 minus 2S. T is 4 minus 2S. That's true. Plug it in there. So 3, 8, minus 4s, 3 plus 2s. The 3's cancel. 6s, s is 4/3. Something doesn't seem to be right there. I think so in this solution, it's saying, let me keep going. T and S do have to be the same. Oh, you know what? I picked, here, let's just keep going. S has to be 4/3. Then if S is 4/3, let's switch colors. 4 minus 2 times 4/3 is T. T is 4/3. And this is consistent. Here, T and S are going to have to be the same because the left side is the same as the right side. And if it's time 4/3 that sends the X piece to be the same as the, or see the X pieces to be the same together, and then the Z pieces to be the same together. All right, so right now, if we were to plug these times back into the lines, we have okay, so if we plugged 4/3, well, I'm not going to do it that way. I was going to find the times for, if we plug in 4/3 and 4/3 in for T and S to see what the X pieces would be and the Z pieces would be. But all we need to do at this point is to figure out if the times 4/3 make us match in the Y component. So for the Y components, let's switch colors again. Y's. So -1 plus 4t, does that equal 2 plus s? So 2 plus 4/3, that's 6/3, that's 10/3. And then -1 plus 4 times 4/3. That's -3/3 plus 16/3. That's 13/3, and it does not equal 10/3. So no, they don't intersect, they are skew. Person point suitcase, let's see. Person pulling a suitcase horizontally along a flat ground exerts a force of 40 pounds at an angle 60. So here's the force of 40, angle 60. Let's call that the 10 feet. And let's do this a little different. Let's say that's the 10 feet. Here you are. Let's make you hot pink. And you're walking this way. Here's your suitcase with the rollers. Okay, so this is our distance vector. This is our force vector. And the force vector has components x and y to it. X is length of the vector cosine the angle. y is length of the vector sine the angle. 40 cosine 60 is a half. 40 sine 60 root 3 halves. So this is going to be 20 and then 20 root 3 for the force vector. Calculate the work done. Work is a value, not a vector. And work is the length of the force, length of the distance vector, dot, is it, I think cosine the angle. Cosine the angle or sine the angle? I think it's cosine. And I'm trying to think why. Length of that dot. So we're dotting in here and length we're dotting. So I think if we had f dot d, that's length of f, length of d, cosine, I think it's cosine the angle, because let's see, f dot d, if the angle, if f and d were perpendicular, then they dot to get 0. And whatever their lengths were, cosine of a 90-degree angle is 0, and that would be give us 0. Okay, so if theta were 90 degrees, then this is true. Okay, so yeah, I believe cosine. Length of f, length of d, cosine theta. Length of d was 40, or f was, and then 10, and then cosine theta, cosine 60 was a half again. So that's should be 200 foot-pounds. Or you could, if you wanted, you could write out foot-pounds. Velocity vector, negative sine t, cosine t, et. Let's see, acceleration vector. Okay, acceleration vector is the derivative there. So acceleration vector would be the derivative of v. That's going to be negative cosine t, negative sine t e to the t. Negative cosine. Find position vector r of t. Okay, so r of t is going to be the integral of velocity being, okay, so negative sine cosine e to the t dt. All right, so cosine of t, sine t e to the t plus constants c1, c2, c3 is equal to, well, let's do this. Okay, so there's your antiderivative. Then if you're going to recover the constants, r of 0 is cosine 0, that's 1, sine 0, that's 0, e to the 0 is 1 plus our constants, and it's equal to 1, 1, negative 1. All right, so for this to be true, C1 has to be, I guess you could work this out. You could do C1, C2, C3 is equal to 1, 1, negative 1 minus this 1, 0, 1 vector. One minus 0 is 1, negative 1 minus 1 is negative 2. So we should end up with vector r is cosine t, let's see, sine t plus 1. And then and what we're doing is I'm adding up cosine t plus the constant, and these are the constants. So cosine t plus 0, cosine t, sine t plus 1, there we go. And then I'm going to have e to the t minus 2. Consider the region bounded by root x and root x plus 1, y equals 0 to y equals 1. Graph. Okay, so let's see. There's my, from y0 to y1. Okay, so there's my root x graph. Root x plus 1 would shift that back there. And I'm needing, let's see. There's y equals 1, y equals 0 is there, and I need this area. So find the area of the region, and it doesn't specify how to do that. So one way would be to realize that if we took all of this red region, actually, let me switch colors. If we took all of this region here and shifted it over, it's the same as this region here. And if we took this region then and added it to this region, then we get this square, and that's 1 by 1. So the area is 1. Another way using the materials we know so far would be, let's see, if we look from x is equal to negative 1 to x is equal to 1, that would be the graph above minus the graph below, but over that time interval or that x interval, the graph above and the graph below switch. So they switch at 0. So let's do area from, oh, and it says label intercepts and points. This is the point 1, 0, 0, 1. And this was that graph. This graph is root x plus 1. Okay. All right, area of the region is going to be area for y. Here, just let me write area. Y0 to y1, and that's right graph minus left. Right is root x minus left is root x plus 1. But we need to write this in terms of y. Root x, so y equals root x is y squared. Oh, no. Yeah, okay. So that y is root x. If I solve for x, x is y squared, and that's my right graph. If I solve in the other one, y equals root x plus 1, that's y squared is x plus 1, x is y squared minus 1. And again, we can get 1 dy because those y squareds cancel. When you anti-differentiate, we get y from 0 to 1. That's going to be 1. Volume of the solid. Okay, so we don't need shells for the shell method. It's not on your exam. That's 6.4. Not. Exam, set up integral from the volume, solid, rotate. Region first quadrant bounded by y equals x cubed, 0, and x equals 2. So let's see. Y equals x cubed, y equals 0, 0, y equals 0 is the x-axis. X equals 2 is somewhere over here. And then y equals x cubed. So if we plugged in, like y equals x cubed does something like this. That would be the 0.28. This is the graph x cubed. 8. This is 0, 0. All right, so and we're finding the volume of the solid generated. So if we're going to revolve that region, so that's our region enclosed by the graphs, the curves. And we're going to rotate about the y-axis. So rotate by y. And it says use the washer method. So says use the washer. Let's see, we're going to have an outer radius. We're going to have an inner radius. And both axes are perpendicular to the axis of rotation, and then measure the distance from axis of rotation to the curve. So let's write that out. Volume will be our y values. So the bounds on our region are y equals 0 to y equals 8. And it's pi big radius squared minus pi little radius squared dy. And it's set up, don't evaluate. So don't evaluate. Pi big radius squared is 2 squared minus pi little radius squared is the horizontal distance out to that curve. And we measure from y-axis out to that curve. The curve is x cubed, but x cubed measures the vertical distance. We want the horizontal distance, which is y, and x in terms of y, if we solve that, cube root y. There we go. That should do it. I'm going to check that, but I think that's right. Yeah. So they listed 4 and they listed y to the 2/3, but also fine. Okay. I know that takes a while, but maybe that's helpful. If you have questions, take care, reach out, and good luck on your exam. All of you can do this. Have a good rest of your evening.